Good day everybody, this is an interesting question. I'm going to show you two ways to solve this question. Now, let me draw the most important shape, which is the circle. And after drawing the circle, let me draw, because inside this circle we got the triangle inscribed. So I will try to get the triangle. So okay. Now there is a tangent here. Okay. As always, figure is not to be scaled. So what it means is, if I were to write here as 3 and 4, don't catch me and say that, wow, 3 is bigger than 4. No, we don't do like that. It's just a representation to give a better imagination what would be the actual scenario that would happen or that is existing. So having mentioned that there is a tangent here, there is a tangent here, there is a tangent here. Now the question wants us to actually get this angle that is situated here. So let me just draw that angle. There is an angle . Okay, so this angle is required and this angle is M. Now this is given to be as 90 degrees. Okay, now let me tell you, the question has already been done by another content maker. I will also show you his method and I will show you my method, or I would say the existing alternate method. Excuse me. So this is the center. Okay, this is the center. We are expected to find this angle M. Now this is 90 degrees. Now what I'm going to do is, from the center O, I'm going to draw a line to D. Now when I do that, I can invoke the tangent theorem. So what does the tangent theorem states? Now if you were to draw a line from the center to the tangent to the circle, then that line would make an angle of 90 degrees. Now because of the figure, you have to adjust with me that you will have a slight what should I say, a differently oriented figure, but this is actually Let me first draw the figure and then I'll explain to you. Okay. Now OE is equal to OD is equal to R. This is the radius of the circle. Okay. Now since it is a radius, by the tangent theorem, if you were to draw a line from the center to the tangent, then that would make an angle of 90 degrees. So there is a 90 degree here. From the center you draw a line to the tangent, that would make an angle of 90 degree. And these two radius, right, these two radius, or the angle between these two radius is going to be 90 degrees. You might be wondering, you might be asking me, how do you say it is going to be 90 degree when you have drawn a figure like that? Now what I wish to tell you is, this is actually a four-sided figure. It's a quadrilateral, right? So the total angle is 360. Now angle, let's start from here. Angle E plus angle C plus angle D plus the angle O should be 360 degrees. Now by tangent theorem, from the center to the tangent makes an angle of 90 degrees. This is 90. This is already given to be as 90. This is also 90. And you got angle O. So you add up all these things. So 360 minus 270. Right? So that would give you what? That would give you 90 degrees. So you don't have to be worried about the way the figure is oriented. We can simply apply the theorem and the concepts and still come to a conclusion that this is 90, right? So because I do not have perfect geometrical drawing instruments, the tools are not there, so I need to adjust. But that is also good in a way, because we are stressing more on the concepts rather than on the visual orientation of the figure. Okay, so having mentioned that, so what happens here, there is a central angle that has been created. And what is M? We are expected to find the value of M. So M is nothing but half times the angle at O. So what is the angle at O? 90 degrees. And that has to be divided by 2. So what do you get? 45 degrees. So therefore M is equal to 45 degrees. That's story done. That's the final solution. Now, excuse me, if you do not apply the concepts which I've shown you here, what would happen? Usually how people will handle this question. I'm going to show that to you. Now, as I mentioned to you, there is a tangent at D. There is also a tangent at F, right? The circle is inscribed inside the triangle, and there is a tangent at F and there is a tangent at D. Similarly, there's a tangent at E, right? Now, let me take this as X degrees, let me take this as Y degrees. So from this is the alternative way, okay? This is the alternative way, alternate method. So what you see here is a triangle. So clearly you know that angle A plus angle B plus angle C is 180 degrees. So that would mean X plus Y plus 90 is equal to 180. You move this 90 to the other side, you get X plus Y is equal to 180 minus 90, which means X plus Y is equal to 90. So this is one equation. Now we have a theorem. What is the theorem? If you were to draw a tangent from an external point to the circle, if you were to draw two tangents, then the tangents would be of equal length. So this is a powerful theorem, right? So that would mean by the theorem AF is equal to AD. So two sides are equal. That means we are looking at the isosceles triangle. So this would mean AD and AF will have or will make the same base angle. Okay, They will have the same base angle, or they will make the same base angle. So let me have A here. So AF is making a base angle of A. That would mean AD will also make a base angle as A. So we got A and A there. Now if you were to, as I mentioned to you, draw a tangent from an external point to the circle, then this side will be same as this side. So that would mean BE and BF will make the same base angle. So let me make that base angle to be B and B, because it's an isosceles and the sides are making the same base angle. Okay, so what I wish to do is, I would like to consider triangle DAF. So let me write that down. Consider triangle DAF. So what do you get if you were to consider DAF? Sum of the triangles is 180. So that means x plus A is equal to 180. That means x plus 2a is equal to 180. So from here I can write x is equal to 180 degrees negative 2a. So that's for the first triangle. Now let me write this down. Consider triangle EBF. Applying the same concepts of triangle, I would get angle Y plus B is equal to 180. So this would mean Y is equal to 180 negative 2B. So let me take this as equation 2, equation 3. I add 2 with 3. What happens when I add 2 with 3? So let me write that down. Adding 2 with 3, x positive y is equal to 180 plus 180. That's going to be 360 negative 2a plus negative 2b. Take the negative 2 out. You get a positive b. Right? Now from 1, x positive y is equal to 90. You can substitute that. So this is 90. I push this negative 2 times of a plus b to the left. So it's going to be positive 2 times of a positive b. 2 times of a positive b is equal to 360. So from here, 2 times of a positive b is equal to 360 negative 90. So from 360 you take away 90, what do you get? You get 270. You have to divide this by 2 to get a plus b. So what is the value of a plus b? You get a 1. You get a 1 and 3, and you carry 1, you get 5. So a plus b is equal to 135 degrees. Right? Now come back here. This side is A, this side is B, and this, I should say, this angle is A, this angle is B, and over here you got M. So by using the properties, sum of all these things should be equal to 180. Right? So considering the figure, we observe that. So what do we observe? We observe that a plus m plus b should be equal to 180. Now that means a plus b plus m is equal to 180, but a plus b is 135. So 135 plus m is equal to 180. We need m. So I'm writing down here. So m is equal to 180 minus 135, which is equal to 45 degrees. So this is the value of m. So you can clearly see the number of steps I have taken just to get m is equal to 45. And it's good to know both these methods, because unless you know the intensity of this method, you wouldn't be able to appreciate the concepts given in the first method. I think this is the right place for us to stop. Everybody, enjoy your day. Thank you. And make sure to subscribe, like and share, and please support our channel. Thank you.